This video will introduce you to the idea of using the addition and subtraction theorems in your proofwriting. So let's talk a little bit first about what the addition property of equality and what the subtraction property of equality really say. The addition property of equality says that when you add equals to equals, the results are equal. So let's take a minute and write that down. And similarly, the subtraction property of equality says when equals are subtracted from equals, the results are equal. And like a lot of things in math, when we try to put it in words, it ends up sounding a lot more complicated than it really is. You've actually used the addition property and subtraction property over and over and over, lots and lots of times when you've solved equations in the past. Now we're going to apply that same idea to geometry. So what this says in the first picture is if I take line segment AB, which I'm going to make red in my picture, and put it together with line segment BC, which I made blue in my picture. So in other words, if I put the red one together with the blue one, the result I get is the green one, the whole thing. So in other words, when I combine segment AB together with segment BC, the result I get is segment AC. And likewise, if I were to start out with line segment AC, the green one, which is the long one, and subtract out line segment BC, the result I would get would be the little one, AB. Or maybe I could start with line segment AC and subtract out the red one, which is segment AB. That would be equivalent to the blue one, segment BC. As far as how this looks as it pertains to angles, again, I'm going to kind of color code. I'm going to make that first one purple, and I'm going to call that angle 1. And I'm going to make the second one blue and call it angle 2. If I were to put angle 1 together with angle 2, the result that I get would be the larger angle, which is angle ABC. Or if I were to start with the large angle, angle ABC, and subtract out angle 1, that would leave me with just angle 2. Or starting out with the larger angle ABC and subtracting out angle 2 would leave me with angle 1. All right, so we do proofs using the addition and subtraction theorem when we have segments or angles that are equal or congruent. So when we talk about this, we can be talking about either the geometric shapes of line segments or angles. If we're given that line segment AB is equal in length to line segment CD, in other words, the two red ones are congruent, and we want to prove that AC and BD are the same, notice that in that picture, the overlapping piece that's included in both of those purple segments would be the blue one from B to C. That's kind of a key or a clue that tells me that I'm going to be using reflexive property here in my proof. Remember that in order to use addition property or subtraction property of equality, you have to have two pairs of parts that you can add or subtract. In this case, I'm going to combine the red plus the blue in order to obtain the purple. Now the red ones I was given in the given information. So segment AB is equal to segment CD. We know that's a true statement because it's given to us to be a true statement. But in order to use the segment addition theorem, we have to have some segments to add. And looking at the segments or looking at the diagram, I can see that the segment I need to add to each of those red pieces is the blue one from B to C. So I'm going to use the reflexive property to introduce BC into my proof. And now if I combine what's on the left side of each one of those equations, AB and BC, and I'm going to go take a look at those in the picture, combine AB with BC, the result I get by combining those is segment AC. And if I take a look at what I have on the right side in my picture, I've got segment CD and BC. So if I look at the picture, segment CD and BC, combine those together, I get line segment BD. So AC is equal to BD, which I just happen to note is what I wanted to prove. And that is the geometric shape that I'm working with is segments. The operation I'm using is addition. And then the word theorem. Your reason when you're using any of these theorems is always going to consist of three parts. The first part is going to tell what geometric shape you're working with. The second part will be the operation, whether it's addition or subtraction. And then the last word will always be the word theorem. That's a nice proof. What's going to be hard for some of you is it's kind of slowing down and going in a step-by-step fashion and something that we kind of already all know to be true. And that can be difficult at times. All right, let's go ahead and see what this might look like in terms of some angles. In the second example, we're told that angle ABF is congruent to angle EBG. So ABF is that large red one. And I notice that angle ABF is made up of two smaller angles, angles 3 and 2. Angle EBG is that purple one, and I notice that he's made up of angles 1 and 2. And we want to prove that angle 3 is congruent to angle 1. Well, I notice if I have the red one and I take the blue one away, I'm left with a green one. And in the picture, if I start with the purple one and take the blue one away, I'm left with a green one. So taking away is another word kind of for subtraction. And the piece that I'm subtracting from both of those is the blue angle, angle 2. So I'm going to use, like I did in the first proof, I'm going to use reflexive property to introduce angle 2 into my proof. So I'm going to go ahead and start with these big angles, angle ABF and angle EBG. I know they're congruent to one another because I'm given that they're congruent to one another. I know that I need to subtract angle 2 from both of those, so I'm going to use reflexive property to introduce angle 2 into my proof. And now I'm going to go ahead and I'm going to use my subtraction. If I look and I take angle ABF, and maybe I want to go red with that one, if I start with the red angle ABF and subtract out angle 2, looking at the picture, angle ABF is the large red one, subtracting out angle 2 leaves me with angle 3. And likewise, on the right side of my equation, if I start with angle EBG, that's the big purple one, taking out angle 2 or subtracting angle 2 leaves me with angle 1. And again, my reason when I use these theorems will consist of three parts. The first part will name the geometric shape that you're working with here. So in this particular case, I'm working with angles. Your second word will be the operation that you're using. In this case, I'm using subtraction. And then the last word will always be the word theorem. Now, a question that frequently comes up is, how do you know whether you're using subtraction or addition? And the answer to that, I think, is a little complicated, but not so much. If you think about the pieces that you're working with, if I look at the picture angle ABF and angle EBG, they're large angles. Whereas if I look at the picture angles 1 and 3 are small angles. Well, the only way that I can start with something large and end up with something small is to subtract something away. And that's how I knew I had to be using the subtraction theorem in that second example. And if I go back up to the first example and apply kind of that same idea, looking at the picture, segments AB and CD, these are small segments, whereas the ones I end up with, AC and BD, are much larger. Well, the only way that I can start with something small and end up with something larger is if I add something to the smaller pieces. And again, that's kind of my hint or my clue to tell me that I'm going to have to be using the addition theorem here. All right, when I look over at the check your understanding questions on the next page, the first one you're going to need a little bit of reflexive property with, but the second one, just a heads up, you do not need the reflexive property. So that's a little bit unique, a little bit different than what I talked about in the video, but I have faith in your ability to handle that. All right, as always, if you have questions or need clarification, please make a note to yourself so that you can ask the next time that you come back to class.